unstructured data is expected to comprise 80% of all worldwide enterprise data. Most of this stays idle. Our mission is to change that and help businesses securely extract value out of unstructured data. A crucial part of this is the ability to detect types of information that are available in a given chunk of unstructured data. For example, the ability to detect the name, email, and SSN in this paragraph allows us to organize unstructured data according to the type of information available, index the chunk to make it searchable by named entities, and protect sensitive information. The ability to classify unstructured data at the token level is invaluable. Currently, most token classification systems employ rule-based mechanisms with tens of thousands of regex patterns. Each type of token can require hundreds of regex patterns, and adding regex patterns linearly increases the system's latency and cost. Additionally, patterns evolve, and some are even difficult to define, such as the case with malicious prompt injection. In contrast, a deep learning solution is able to capture linguistic nuances and latency stays constant regardless of the number of token types it can detect. This is what makes a deep learning-based solution attractive. Yet it has its own challenges. Most of them require GPUs to meet the throughput requirements at scale, making it prohibitively expensive. Additionally, deep learning solutions require training data that looks as close as possible to the input during inference. In some cases, this data is sensitive. For example, if you're a company that handles health records, insurance policies, or contracts, you're going to want to train your models on similar data, which means you need a way to train your models on sensitive data without compromising its security. ThirdAI has built a platform to overcome these hurdles. The ThirdAI platform lets you easily build deep learning models for processing unstructured data in an air-gapped, on-premises, CPU-only setting. Let me outline what we'll demonstrate today. First, we want to show you that our token classification models perform well out of the box. Second, you can easily enhance this model with your own data, all while keeping it entirely on premises. Third, model latency remains constant regardless of the number of tags detected, allowing you to expand coverage without sacrificing throughput. Lastly, we want to show that our capabilities extend beyond PII detection by demonstrating models for document classification, malicious prompt detection, as well as HIPAA compliance. Let's dive into the demo. On our dashboard, you can see a range of models, a HIPAA model, PII models with different numbers of tags, a malicious prompt detection model, and a contract classifier. I would like to start with PII 16, our PII model, which can detect 16 different tags. To give you a feel for whether this model is reliable, I will pass in a CSV file that contains several samples. This file contains several records, and even just glancing at it, we can spot several tokens that should be detected by the model. We see a name here, an SSN, some IDs, email, and so on. When we upload it, the platform parses the CSV and sends each sample into our PII model. In the first sample, we found an email, an address, an ID number, a name, as well as a date. In the second example, we also found an SSN, a vehicle identification number, a phone number, and as we scroll down, we'll find other examples where we have other types of information such as the credit score. So that was an interactive demonstration of the model's capability to get a feel for the model's performance. To see how it translates to numbers, we can go back to the home screen, go to the PII 16 row, and click on Usage Dashboard. On this screen, we can find the accuracy numbers per tag on the last evaluation set, averaging out to about 95%, so the performance is solid. You may also have noticed that there are two sets of numbers, one before fine-tuning and one after fine-tuning. What is fine-tuning? It means providing the model with additional data that mimics the input data during inference, thus allowing the model to adjust itself to get better at specific business problems. We used this exact process to develop this model. The first iteration of the model had lower accuracy, but we fine-tuned it to improve it. In the last fine-tuning iteration, the model improved from an average of around 90% accuracy to around 95%. Now, this powerful capability is made available to you so you can improve the model accuracy on your data from 90% to 95%, 98%, and beyond. You simply have to upload a fine-tuning dataset and give the new model a name. The fine-tuning dataset looks like this. There is a column with input samples and a column with the target tags. Tokens that should not be tagged are marked with O's. Let's select this dataset and initiate training. At this point, the platform spares 10% of the data for evaluation and trains on the rest. The evaluation set is used to give us these metrics. If we go back to the app catalog, you will see that the platform has queued a training job for the new model, which incorporates the fine-tuning data that we just uploaded. And remember, this entire process happens on-prem in an air-gapped setting so that your data never leaves. To help you with the fine-tuning process, the dashboard also displays other helpful information, including more detailed metrics and examples from the evaluation set that the model excelled at, as well as places where there is room for improvement. I will copy the sample for later. This information is made available to you to guide your data curation process. As always with learned models, harder samples allow the model to learn more effectively. If we keep scrolling, you will see a section called Update Model with Recent User Feedback, which is currently empty. I'll show you how it gets populated. Let's go back to the inference screen of the PII model. I just pasted the false positive sample from before, and as expected, it missed a tag. When it does this, the user can simply click on the token that the model missed and select the right tag. Once they're done, they can click Submit, which then tells the platform to log the feedback. As expected, the feedback now appears in the user feedback section of the dashboard, so that is another way that you can collect fine-tuning data. Once you collect an amount that you're satisfied with, you can click Update with user feedback to incorporate that into your training set. We have just shown you that the model performs well out of the box and that the platform has fine-tuning built in. You can upload a tag dataset, or you can collect tag information through the UI and incorporate these data sources into the model's training routine. The next thing I want to show you is how latency stays constant regardless of the number of tags that the model supports. Let me open all three PII models, PII 5, PII 10, and PII 16. When I upload my test samples from before, the PII 5 model was able to tag these samples very quickly, as you can see on the right. I can upload the same samples to PII 10 and get the same inference speed. I can upload the samples again, this time to PII 16, and still get the same inference speed. The reason that our models scale so well is that we use a neural network, which means that the only thing that changes when we go from 5 to 10 to 16 tags is the size of the output layer. The rest of the network stays the same. This allows for unprecedented scalability with respect to the number of tags. The inference time still scales linearly with respect to the number of tokens in the sample, since the model needs to predict the tag of each token. But it won't change no matter how many tags the model supports. That concludes the PII part of this demo, but PII detection is not all that we offer. To demonstrate how this technology extends beyond PII, we'll show you a malicious prompt detection model, a contract classification model, and a HIPAA tag detection model. We'll first visit the malicious prompt detection model. With the rise of generative AI, it's essential to differentiate between benign and malicious prompts. However, it is not obvious, oftentimes, whether a prompt is malignant or not just because the keywords aren't always clear-cut. For example, we have a prompt that aims to ignore common perceptions about World War I, presumably to rewrite war history. What keywords actually make it malignant? Is it the mentioning of World War I? The blank canvas? The word deliberate? Not necessarily. Here is a completely benign prompt that has the same exact keywords, but all it asks is to write a poem about sacrifice. So it's really important that a model can read between the lines. Let's go back to the app catalog, open the malicious prompt detection model, and fire the query about rewriting war history, which the model identifies as malignant. When I fire the query about writing a poem, it determined that this prompt is benign with sub-millisecond latency. Fundamentally, this is a text classification capability, and it can be extended to other use cases as well, including document classification. So let's try that out too. In this folder, I have a couple of contracts, each of a different type. There is a maintenance contract here, a franchise contract, a transportation contract, as well as a service contract. The catch is that they all have had their titles removed. So for example, if we click on maintenance here, we'll see that the whole contract is there, but the title, which is usually a huge giveaway, is not there. So we're going to force the model to figure it out based on the content of the documents alone. To run the model, I can either type something into the text bar or I can upload a file. I'll select the file that I showed you earlier, which will be parsed by the platform into chunks of text, and as you might expect, it successfully classified the file as a maintenance contract. I'll select a different file, this time a franchise contract, and the model was able to successfully predict that too. Fundamentally, both this and the previous model are text classification models. They take the entire text and classify it. It extends beyond malicious prompt detection and contract classification into any sort of classification task. For example, you can use our platform to build a model that can distinguish between different types of documents so you can process it downstream in different ways. If it's a contract document, you might want to detect and redact PII information. If it's a health record or a hospital visit log, you might want to detect and redact HIPAA tags. Speaking of HIPAA tags, one final thing that we'd like to show you is our HIPAA tag model. Similar to our PII model, it can detect sensitive information, but this time it conforms to the HIPAA standards, so it detects some information that the PII model does not. Suppose you have a hospital visit summary that has details about the patient number, the hospital, identification numbers, and other sensitive information. Maybe it came from a stream of strictly hospital records, maybe it came from a combined stream of various document types, and you used our document classification model to route a document into this HIPAA tag model. Either way, when you pass the text into this HIPAA model, just like before, it will tag each token very quickly. Inference time per token stays constant, even though this model detects more tags than before, scaling only with total tokens processed instead of supported tags. And of course, you can fine-tune this model just like the PII model, either by passing a tagged fine-tuning dataset through the usage dashboard or by providing feedback through the UI. To recap, we have demonstrated an enhanced PII detection capability, on-premises fine-tuning that respects data privacy, scalable performance with respect to the number of supported tags, as well as extended capabilities beyond PII detection, demonstrated by malicious prompt detection, contract classification, and HIPAA tag detection use cases. All of this is available in a platform that is air-gapped, on-premises, and CPU only. We hope you're as excited about these developments as we are. Thank you for your time, and we look forward to discussing how we can help solve your specific challenges.